I'd like to show you a real-world example where we used the Alberta Directive 15 setback distances in another province that had no setbacks for a gold mining operation. And in this diagram here you can see we've got an area, we've got the subsurface lease area. Below it we've got the horizon of interest, and obviously in that orange oval would be the whole area we'd want to make sure we had good imaging across. Now typically you can have sources and receivers, and you can transpose them and have them replace each other. But in this case, the whole area on the right hand side was very wet and we could not get our sources over there. So we were limited to the other option like this for the recording of this horizon. To record that horizon, we would continue moving with our same geometry and move across until we got right up to town, but we'd managed to successfully image that whole horizon. The problem was, where we were working, it was actually a dipping horizon, which changes the geometry completely. And this makes the reflection point move up dip. So in order for us to record this area of the subsurface, it meant we had to move our source points further and further into town to do that imaging. And that's what I'm going to show you. This was the route through town for the seismic vibrators. And these are the two vibrators operating through town. These are two IVI Enviro Vibes. These vibrators weigh 17,000 pounds each, and when they pull up and they put the base plate down, they actually put the base plate down with 15,000 pounds, so there's 500 pounds left on each tire, and that keeps the vibrator from operating like a pogo stick. So it's actually got a hold down weight that keeps it stable. This is a vibrator moving into position. You'll get to see the base plate and the mass. And we start at a low frequency. And to do that, you will see displacement of the mass. But once we get above 15 hertz, then you can no longer really see the mass moving. So that'll be coming up here shortly. So in doing this with the Alberta Directive, we're actually with vibrators that are operating at 22,000 pounds with the two of them. And we're in 4 different classes. So we've got B, C, D, and E, all different specified structures, all with different setbacks. And so prior to doing this, we actually did some testing in the local condition with the 2 vibrators to make sure everything was safe. And we were getting 6.8 millimeters per second at that 4.7 meters offset. And again, just doing another sweep, picking up the pads and moving on. This is just some more footage. What was huge about this is because we had the Alberta Directive, we were able to work with the client and the contractor, but also with the residents and with the mayor and city council, because we're working all through town by their infrastructure with our equipment. So we needed to have all of that in place, and having the Alberta regulation that was well defined for different energy sources and different fundamental forces and or charge sizes at different offset distances, that was really made it self-explanatory for everybody as to what we were going to accomplish. And then here's another example. This is in LA, so it's actually a geotechnical survey to study for a safe location to put a subway station. This is just some other work of interest. We did some work on the Trans-Canada Highway. This video footage is sped up a little bit to make it go by quicker, but you can see we've got the signaling people and we've got the vibrators. And here we're just flying overhead. We're at about double speed here, just to speed it up again. But what was interesting about working on the Trans-Canada was there were certain places where there was certainly structures of interest there. And here we're moving up towards a bridge abutment. We stayed back with the sets of vibrators from the nearest pad, 16 meters, and we would have anticipated the vibration to be about 2 millimeters per second at 16 meters offset. So we had two sets of vibrators. The front set were shaking all the odd stations, and the second set in the back were shaking the even stations. So they were staggered working up the highway. And then we had to wait until both vibrators were ready, and then we moved across the highway, so we just had to stop traffic for a while. At this point, our lead vibrator, one of them had a problem, so it carries on forward to a staging area where we could work on the vibrator, and then the back set of vibrators proceeded just past the bridge abutment and the concrete, got set up. They shook all the way forward to where the other vibrators were waiting and being serviced. And once again, because of the extensive work that had been done in Alberta with vibrator monitoring and the local testing we had done, we were able to conduct our survey, getting close to these structures, and have a good continuous data set.